Good morning. So yeah, my job with the division is watershed coordinator, essentially coordinating Utah Lake water quality study for the division. And as Dr. Richard mentioned in his opening presentation this morning, we're part of our collaborative effort. He had referenced this study in particular as part of that collaborative approach for addressing water quality conditions on Utah Lake. And so about a year ago or so, the Division of Water Quality initiated, or reinitiated, I should say, a water quality study to look at the interactions of nutrients in Utah Lake and to see if they have any impacts on the beneficial uses. This is an aspect of the study that's pretty specific to the Division of Water Quality, where we're mindful of protection of the beneficial uses in the lake. And then I would say the second purpose of the study is really to try to drill down through the scientific process and see if we can establish numeric nutrient criteria endpoints that are protective of the beneficial uses in the lake. So there are a number of contributing factors to why the division took on this effort again. And one is, this is, like I said, a continuation of a previous study that we completed in 2008. And that time we developed a report that kind of gave some estimates for nutrient loading to the lake and a little bit of nutrient cycling in the lake, and also a good generalization of data characterization. But at that time, there was a little bit of a disconnect between what the nutrient concentrations in the lake really meant for the beneficial uses. So we decided on that realm to step back and kind of take a look, continue on with some additional monitoring, and see if we can better establish that linkage between the nutrients and the beneficial use. Also around that same time was the initiation of the carp removal program for the June Sucker Recovery Improvement Project. And at the time it was expected that carp removal program could have some serious implications to nutrient cycling in the future for Utah Lake. So with those two contributing factors, we decided to take a step back, let some of those things play out, and then revisit it at a later time. So Utah Lake is listed on the 303D list of impairments. It's actually one of our oldest nutrient impairments on the books. And with that, there's some additional evidence that I'll describe here in a minute with some new water quality impairments related to nutrients that are just now being identified. And then, of course, the recent attention that the lake has been getting over the last few years with harmful algal bloom episodes. And the last one here, the regulatory certainty, as the POTW community is navigating their implementation of the technology-based phosphorus effluent rule that the division instituted in 2014, the community is asking for some certainty on, okay, if we meet these technology-based limits, how much lower are we going to have to go in the future, given any particular range of outcomes for the study. So one of the big driving factors for this study is to be able to try to drill down and figure out, what do we need exactly in terms of site-specific criteria for protection of the beneficial uses in the lake. Okay, I'll just glaze over this pretty quick here, just to show that we anticipated a three-phase study. Phase one is where we're at now, where we took on a number of tasks to try to gather the information and the science to inform the decisions that we would make in phase two. And then phase three was more of an implementation of the recommendations. And I'll go over a little bit. That's changed how we're thinking about this over the last little while, and I'll describe kind of the new approach a little later on. So phase one, when we kicked off the study a little more than a year ago, we had borrowed from the Utah Lake Commission Technical Advisory Council stakeholder group, just kind of as a foundation for the original stakeholder group. That group has continued to grow throughout the last year or so, nearly 90 representatives from a broad range of interests. And so we're continuing to work with those folks and keep them engaged. And to help support our efforts for the tasks here, tasks 2, 3, and 4, we've developed smaller subgroups of stakeholders to help us with the technical guidance for developing the work in those tasks. Okay. So the first of the real tasks, I guess, for the project was more of the, we recognized at the outset of the project that there was a lot of other folks doing work on the lake. The Jordan River Farmington Bay Water Quality Council, Dr. Richards, all of the universities, essentially, local universities. So we initiated an effort to try to collaborate with all those folks, bring everybody to the table so that we could communicate and do this stuff in coordination so that we're not repeating or duplicating efforts, and then we all can share information and come to a common end with that effort. The second main part of this task was to basically reach out and find all the different data sources that might be relevant to the project and then compile those into a publicly accessible database that all the stakeholders in the public can use throughout the process. And then ultimately have that lead to a data gaps analysis where we can have that be the driving factor for future monitoring to get those missing pieces that we feel are critical for the project. And the last one here is it's a pretty significant one, I think. And this is just dealing with looking into the scientific literature, into the studies that have already been conducted on Utah Lake, and then gain the information that we need to out of those to kind of guide our efforts in the future so that we can learn from the things that we've tried to learn before and apply those to the task at hand as we move forward. The beneficial use assessment component. So far, the work under here, like I said, as the division, we are focused on protection of beneficial uses. And so kind of first cut at this task was to take all the water quality data that we had and then see if it's supporting our beneficial uses or if we have any impairments. So the initial work conducted with this is mostly related to the work that we've done under the 2016 integrated report. And we'll be working in the next couple months to include data that has been collected since in 2015 and 2016, since the data cutoff for the integrated report was in 2014. So we'll bring that current. And then also we'd like to take a look at how we approach some of that beneficial use assessment in terms of what are the existing uses and are they appropriate. For example, the recreational beneficial use here, there's some consensus. It seems that the infrequent contact recreation use that's assigned to the lake might not be appropriate for the uses that are actually occurring on the lake, like water skiing, where there would be a high likelihood of contact and ingestion of water. For the aquatic life uses, we do a pretty good job at evaluating whether or not they're supported uses, but we'd like to expand that assessment to include an evaluation of early life stages for aquatic organisms, for juvenile fish, protection of juvenile fish and rearing and that kind of thing. And then also the evaluation of the secondary water uses. The water is used, as most people realized, as a result of the harmful algal bloom this past summer, but the water from Utah Lake is conveyed downstream to a large portion of the Salt Lake Valley. And we'd like to be able to come up with some kind of way to assess the secondary water use for folks that are putting it on their lawns, irrigating their gardens, and also for the agricultural community that widely uses the water downstream. Okay. So the fourth task is a kind of a reevaluation of the work that we did in 2008, and this graph is right from that 2008 report. We had set out to revise the water budget and then kind of what we were calling a bulk load analysis. And there was consensus among the stakeholders that the proportionate of this loading was not, the loading distribution could be slightly skewed for a number of different factors. One, nutrient uptake in tributaries. Wastewater treatment plants have continued to get better at their level of treatment, and concentrations being discharged are a lot lower. So we set out, with the idea of being able to refine those estimates. And I think the Jordan River, Farmington Bay Water Quality Council folks and a contractor are looking at some of that work right now. One of the big questions with that load analysis is that we think that we underestimate sources from the agricultural community and from stormwater runoff. So we're looking into some of the land use distribution analyses to kind of put some sidebars on where we think the loading could potentially be from stormwater sources to help guide future work under Phase 2. And then for the wastewater treatment plants, like I had mentioned, the load analysis that I'm seeing now are pretty similar load estimates to what were developed in 2008. The loads are the same, but like I said, the treatment plants have made progress in decreasing the nutrients that they're discharging. And so we have lower concentrations for a handful of the wastewater treatment plants, but flows are going up as population increases, so the loads are roughly equivalent to one another. So we'll continue to work on that element. So task 5, this is our model selection. We had set out at the beginning of the study to develop a water quality model that will simulate conditions in Utah Lake and be able to guide us in our decision making, being able to determine what appropriate endpoints would be for protection of the uses. And so the initial part of that work was to evaluate all the water quality models that are available for this work and then see how well they fit with the unique conditions of Utah Lake. And so we had finalized that report this summer, recommending the WASP model for doing the water quality side of things, and then the EFDC model for doing the hydrodynamic modeling portion of it, so moving water from place to place. But on a parallel effort, the University of Utah last fall, and I believe they may have made a presentation of this project to the symposium last year. Yeah, so applied for an EPA grant, a rather large one, and got the grant to look at eutrophication in the Jordan River and Utah Lake basins as a function of climate change and urbanization. And so rather than developing competing models where the Division of Water Quality develops one and might not have the same answers as the University of Utah, we've decided to partner with them and have the university lead the modeling effort. And Dr. Goel's on that team, along with Michael Barber, he's the principal, Steve Burian, and Sarah Heiners, I believe. So we'll be working in collaboration with the university on model development. The idea here is that they'll develop a calibrated water quality model, deliver it to the Division of Water Quality where we can make use it for programmatic decision-making processes. So phase 2, we've kind of rethought how we were going to approach phase 2. Originally, we thought that most of the work would be done and we'd be able to go into the programmatic side of things. But one of our first things that we're reevaluating with phase 2 is our stakeholder process. The stakeholder group is growing rapidly. There is a lot of interest, a lot of people who are really invested in the interest. And we thought by developing a more formalized process that we could better partner among stakeholders and develop a more transparent stakeholder approach. And so one idea that was pitched to us, and is a similar idea that we've applied to other projects in the division, is development of a steering committee that is formed of a number of representatives from the various stakeholder groups. And they would conduct that transparent process. One of the main goals would be to establish a science panel. So the science panel would then guide the scientific process and identify the gaps in the science, make recommendations for future studies, and then provide a process for independent peer review of that work, and then ultimately make recommendations back to the steering committee for consideration. And then the idea would be that the steering committee can make a recommendation on nutrient endpoints to the Division of Water Quality. So this schematic, I guess, is just meant to show that the idea here is that we intend to establish numeric nutrient criteria, and we would like to do that through this revised steering committee process. So, and as many of you have heard, we made a proposal to Utah Water Quality Board last summer, casting a couple broad research questions for funding, and received $1 million funding to put towards the project to help answer some of those scientific questions. And like I said, we put forth a number of really broad categories of questions with the intent of having stakeholders revise those questions and really drill down and guide the work in the future. So the first one of them are, the nutrient dynamics in the lake. How is nutrient cycling being conducted, and how does that relate to our ability to predict and make recommendations for numeric nutrient criteria? Nutrient mineralization, bonding with calcium carbonate, is a big issue in Utah Lake, and it's pretty well known that the mineralization is pulling nutrients out of the water. But then there's the issue of legacy loading. If we were to implement a water quality strategy that required nutrient reductions, how long of a time will we have until we could realize a benefit from that based on the nutrients that are stored in the sediments currently? And so those will be things that we intend the stakeholders to drill down in and kind of refine the questions. Similarly, the ecological dynamics, the carp removal program is expected to have some pretty big implications. As David Richard said in his presentation, the food web dynamics here in terms of nutrient cycling can be huge. So to develop, we set aside some funding for this to take a closer look at some of the key interactions there, and to be able to, hopefully that can help us predict some of the nutrient interactions in the modeling. And then, also to take a little closer look at the historical conditions in the lake to, help us get at what an achievable endpoint would be for the lake. And it's, this project in no way is meant to restore the Utah Lake to pre-settlement conditions, but there is some kind of reasonable endpoint that I think we can achieve based on some of this work that will allow this study to guide that process. The loading characteristics, this is another big one, how and where the load comes from throughout the watershed, the timing of it, and then how that's going to change with population growth and urbanization. This graphic shows the black line is the expected population growth in the Utah Lake Basin. The blue bars are the projected wastewater effluent in million gallons per day. And so as population increases, the wastewater discharge is expected to increase as a function of population. But we also recognize that other sources are going to increase as well. Non-point source distribution and timing will change as a function of that. So being able to put forth some questions and study how those dynamics are occurring and be able to incorporate that into our nutrient project, I think, are a pretty key part of it. And then, the nutrient conditions in the tributaries. There's some uptake and some other things that are going on in the tributaries that affect nutrient loading to the lake. And then the last set of questions here, we have a desire, and I've heard it from a number of stakeholders, to kind of better describe what recreational users would like to see from Utah Lake. It's probably not a crystal clear water body, but at what level are recreationists comfortable with the conditions of the water quality conditions in the lake? And then how do the recreationists respond? Do they change behavior when water quality conditions become deteriorated, or during a harmful algal bloom or something like that? And then there's been some interest in being able to establish a predictive network for harmful algal blooms in Utah Lake. So we've set aside a little bit of work element to be able to look at the linkages between HABs and nutrients. And then also, being able to do things like looking at evaluating satellite imagery to see if we can develop some correlations between algal concentrations and that kind of stuff. And then looking at the economic and social cost of harmful algal blooms. Okay. One of the big questions that we had, and we received a number of phone calls from a number of different companies throughout the harmful algal bloom this summer, and that was proposals for treatment options. And we would like to develop a network partnering with the Utah Lake Commission to be able to set up a structure to evaluate those proposals and to be able to respond accordingly. Okay, just a couple more things here. In addition to the water quality, the $1 million funding that we received this summer, we also received $100,000 approximately from the Water Quality Board earlier this spring to establish a buoy network of high-frequency water quality sondes throughout the lake to help get at some of the, with the intent to be able to have this feed the water quality study and to develop a prediction network for harmful algal blooms in the future. So we have 3 high-frequency sondes, collect data every 15 minutes, telemetered to our data source on the hour. And then in addition to the typical water quality parameters, we have chlorophyll, blue-green algae, and then one that I don't have listed here is turbidity, which we think are pretty key components to being able to develop those relationships. So if you go to the website, you can click on any one of those monitoring locations, select a parameter of choice, it'll give you a graph. So it's really interesting to be able to pull them up and see them side by side, and this idea of what the buoys look like. And then finally, we've been working on an effort, to establish a local watershed coordinator. And the division approaches non-point source implementation in the state of Utah by putting local watershed coordinators throughout the state to be with the specific focus of implementing TMDLs and improving non-point source water quality problems. And so we've recently partnered with the Utah Department of Agriculture and Food to establish a local watershed coordinator in the Utah Lake Basin. And then we'll split time between kind of the area, the Provo River watershed, up in the Heber Valley area, and then the Utah Lake. And for the Utah Lake component, we feel that this position will primarily be focused on establishing a technical committee to evaluate potential non-point source contributions, and then follow that with development of a monitoring plan, monitoring of non-point sources, and then a further characterization of the magnitude of those, and then participate in some HAB monitoring to help out in the summertime. So I guess with that, I'll take any questions.
Questions for Scott?
I was just wondering, as you're combining data, are you looking to like comparing their SOPs, like how they did the samples, to determine like if the data is even valid to be combined, because different procedures, they take samples differently and the data might not be the same. So
right.
I was just wondering what you're doing about that.
We did exactly that through our work group that was working on that task. All the researchers and data collectors submitted their SOPs. All had a common understanding of how collection methods and analysis, and so I feel like.
For example, UOFU project is EPA funded, so we are required to have a QF approved by EPA. So it's just not DWQ, but EPA and DWQ, so it's pretty robust.
So like, I'm not opposed to more study, and that's fine, but what's being done now? I feel like we know enough that there are certainly actions that could be done, and you said that the wastewater treatment plants have made some improvements. I'm curious, what is the phosphorus concentration in their effluent compared to, say, a treatment plant on Lake Champlain in Burlington, or like, what is their range in terms of, are they the worst of the worst? Are they somewhere in the middle? And then maybe if you can mention other efforts that are currently being done to improve the water quality of Utah Lake already.
Okay. Yeah. So in terms of the wastewater effluent, there's, like I mentioned, that technology-based effluent limit rule that the division established last year. It takes a technology-based approach, water quality conditions aside, and says you need to meet 1 milligram per liter of discharge into the lake. So by doing that, we expect to see some reductions in nutrients. And I think in terms of the range, and I have to look at the numbers, they're between 3 and 6 milligrams per liter. Some may be higher, some may be lower for the discharging facilities around the lake. And certainly they're moving towards making improvements. We've seen, like I've said, we've seen some already do that. And then in terms of other water quality studies, I mean, this is, everybody kind of has their own individual piece, but this is what we feel will be the connecting piece to bring it all together and kind of make sense out of the recommendations. We haven't made progress towards non-point source controls in the Utah Lake Basin so much, so we feel like that's a pretty good opportunity. That's outside of the realm of study. You got to do some work to characterize where things are coming from, but we can go down that road and start making improvements on the non-point source front right away.
Just one more question.
Well, a statement, not a question, so I'm going to make this real quick. There is a coordinated resource management planning effort right now underway on the Spanish Fork River, which is the tributary to the south. So there are some very early stages, but we, Division Water Quality, are interested in supporting and growing that.
Well, I think we ran out of time, Scott. Thank you very much.
Thank you.
We'll just break for